Welcome to this month's Pacific Northwest DEWS Drought and Climate Outlook webinar. Before I begin, I'd like to remind everyone to keep their microphone off. GoToWebinar has turned all of our cameras off for us, but trust us, we all look marvelous. Please post your questions in the question and answer box, not in the chat box. My name is Erica Fleischman, and I'm with Oregon State University. This bi-monthly webinar series is hosted by NIDUS, the USDA Northwest Climate Hub, and the Oregon Climate Change Research Institute. It is designed to provide partners and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climate events. Each webinar also discusses observed impacts and other relevant updates from across the region. Webinars and recordings and other supporting materials will be posted on drought.gov later this week, and if you are signed up for our emails, you will receive notifications when those are available. After the webinar, you will have an opportunity to provide feedback that may help us improve this webinar series. Please take a moment to tell us what you think. We have 4 terrific speakers today: Karen Bumbaco, Amy Burke, Sergio Arispe, and Amy Garrett. Again, we're going to use the question and answer box at the right side of your screen for questions during the presentations, and we will do our best to address those during the question and answer period after the presentations. Before we begin the presentations, we'd like to highlight the partners who make this series possible. The Northwest Climate Hub develops science-based, region-specific information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. And links to all of these partners and other information should be showing up in your chat box as we go. The Oregon Climate Change Research Institute, or OCRI, is a network of researchers at Oregon's public universities who work with public and private entities to advance understanding of regional climate and climate adaptation. OCRI is administered by Oregon State University and hosts the Oregon Climate Service, the Office of the State Climatologist of Oregon. And the 7th Climate Assessment, which came out this past January, a link to that will be dropped in the chat along with, or actually it's just available on OCRI's website. So please see the links to the Climate Service and OCRI in the chat box. NIDUS was established in 2006 by public law, and its mission is to improve the nation's capacity to proactively manage drought-related risks. NIDUS provides the best information and resources available to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDUS maintains the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and interested and effective parties share information and actions that help communities cope with drought. Although the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ among regions. The regional DEWS have many of the same basic features, but each has distinct aspects to reflect the needs of its region. The Pacific Northwest DEWS was launched in February 2016, and a strategic plan and information on current activities are available on drought.gov. To facilitate the early warning system, more precipitation observations are needed. We encourage you to join CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Network. CoCoRaHS is a unique, nonprofit, community-based network of volunteers of all ages and backgrounds who work together to measure and map rain, hail, and snow and to report conditions. Observations by CoCoRaHS participants of precipitation and the lack of precipitation are important ways to capture and improve understanding of weather. To become a volunteer or to learn more, please visit cocorahs.org or contact your state coordinator. And names and emails of those coordinators will be in the chat. Understanding how drought affects you is important for drought assessment at state, regional, and national levels. The National Drought Mitigation Center Condition Monitoring Observer Reports, or the CMOR system, is a great way to submit the impacts you're experiencing from too much or too little water. Becoming a regular observer makes this information more accessible to those who assess drought in your state. And we also pull from this system for the annual Pacific Northwest Water Year Impact Assessment. There will be a link in the chat that allows you to go to the Seymour website and watch a how-to video, learn best practices, and access social media and fact sheets. And starting in 2018, the snow drought status updates for the water year we started in 2018, and those are continuing with the next update being released on May 1st. These updates provide timely information on snow conditions across the West with an emphasis on snow drought. And so you can access the April 1st snow drought update now, and later this week you will be able to access the May update. The 2024 Pacific Northwest Impacts Assessment has been released. The impacts were gathered in two separate, similar annual water year recap and outlook meetings, one focused on Washington and Oregon and one on Idaho. Also, the University of Washington Climate Impacts Group and Washington State Climate Office distributed the annual Pacific Northwest Water Year Impact Survey across the Pacific Northwest. The link to the document is in the chat. The Washington State Department of Ecology has issued a drought declaration for the Yakima Basin watershed and a drought advisory for watersheds in the counties of Whatcom, Skagit, Snohomish, King, Pierce, Okanagan, and Chelan. A link to the formal declaration and information on financial assistance will be in the chat box. There are new ways to stay in touch with NIDIS. In the past, if you registered for our webinar, we were able to add you to the Pacific Northwest DEWS email list so that you would receive the recording. This is no longer the case, so if you came across this webinar in any way other than a direct email and you want to receive the recording and other pertinent information, please follow the link in the chat to sign up. You also might be interested in the biweekly Dry Times newsletter and the Tribal Engagement newsletter. All right, thank you to all of our speakers who will be presenting today. We will provide all speaker contact information and presentations after the webinar, and our next webinar will be on June 23rd. All right, so I am going to stop sharing, and I am going to turn over presentation to Karen Bumbaco. Karen, we have about 50 minutes total, so I'll give you a heads up after about 11 minutes.
All right, great. Thank you, Erica. So I'm going to jump right in since time is tight and start with the water year 2025 sort of summary so far. So on the left-hand side, we're seeing temperatures from October 1st of 24 to just last week. And then on the right-hand side is the precipitation anomaly for that same time period. So overall, temperatures have been on the warmer side. So all those reddish colors on the left mean above normal temperatures for the water year so far. If you look at just the rankings from October through March, they each individual state in the Pacific Northwest ranks among the warmest quarter of the record. So records go back 130 years. Idaho tied as the 15th warmest October through March, 19th warmest for Oregon, and 26th warmest in Washington. So on the warmer side for sure. For precipitation, what sticks out on me on the right-hand side is the wetter than normal precipitation across Oregon. So that has been above normal for the water year. Looking at October to March, it's the 27th warmest on record, about 118% of normal. If you look at the precipitation averages in Washington and Idaho, they pretty much balance out to near normal for that time period, so not especially informative. In Washington state, there's been a distinction between the western Washington and eastern Washington, where east of the Cascades has been a bit wetter, and in western Washington, it's been drier to near normal. For Idaho, across parts of southern Idaho and in the northern panhandle have been a bit on the dry side, which and then the locations that border Oregon and Washington have been normal to above normal precipitation for the water year so far. So if you look at just the last 60 days, so this is going back to the end of February through last week, our temperature anomalies are greater for just those last 60 days, seeing between 2 and 3 degrees Fahrenheit above normal temperatures across the Pacific Northwest. For precipitation, we finally did start to see some much needed precipitation in western Washington and in northern Idaho when it's been dry overall before the last 60 days. Um, and then for the last 30 days, we're seeing continued warm temperatures across the Pacific Northwest, particularly west of the Cascades in Washington and Oregon. And then we're also starting to see some drier than normal conditions around the Pacific Northwest. April will very likely come in with below normal precipitation numbers for each state. And then I wanted to point out specifically southern Idaho, where for the last 30 days they've received less than half of their normal precipitation across much of that region. So backing up a little bit to early April, so this is typically when we see the most amount of snow in our mountains in early April. This is the percent of median around the Pacific Northwest. And there's definitely a distinction in snowpack between the northern regions where it's been more below normal and the southern regions where they've enjoyed above normal snowpack. Those statewide numbers I have written down on the bottom of the slide there. On April 1st, Washington fared the worst with 87% of median snowpack by that kind of peak time. Oregon, much above normal, 137% of normal. And then you can also see that distinction in Idaho as well. So north of the Salmon River, just slightly below normal on average, and then south of the Salmon River above normal snowpack in Idaho. So take a look at this map because I'm going to switch to the next slide and it'll show the same map at just a later date. So this is April 1, and then this is April 23rd, so at the end of April. And what you can see here is the percentages of snowpack compared to median dropped compared to April 1st, which is indicative of a faster than usual snowmelt that's going on. This is mostly apparent in Washington and Oregon. So in other words, now those percent of normals are lower because it's melting out a little faster than usual due to our recent warmth around the Pacific Northwest. And we can see that I'm going to show these traces in snowpack for each state. So just to orient you, this black line is the current season. The orange line is 2004. So overall, snowpack is better across the entire Pacific Northwest compared to last year. This is average just for Washington State, and then those shadings are the different percentiles. So on average, all of the snow stations in Washington have been normal, slightly below normal. The green line is median, but you can start to see the slope of that line. Oh, I have my cursor here. So here in April, it starts to drop a little faster, approaching this sort of below median number on average for the state of Washington. And we also see this similarly for Oregon. So this black line much above normal snowpack for the water year, but you're starting to see it kind of drop pretty quickly into this normal area. So we're expecting to see snow melting out a little earlier than usual, even though I guess I shouldn't say earlier than what otherwise would have been if we had a slower melt where it's going following sort of this curve of along those blue lines. We're not really seeing that in Idaho. Melt out looks to follow right along that normal line, which is great news for Idaho snow. Okay, so it was already mentioned in the beginning that there was a drought emergency for the Yakima regions in Washington state. So this covers Kittitas, Yakima, and Benton counties. Um, and the drought advisory in these counties here, where we're keeping a close watch, and this was mostly due to the below normal snowpack that we've seen across this part of the state. But the below normal snowpack is not really the whole story. So last year really plays a big role into why that drought was declared in the Yakima Basin. So this is showing the collection of reservoirs in Yakima. So normal is this red line, last year is this green line, and the current year is the blue line. So the reservoirs are much below normal, and they started the water year that way because last year was also a drought year. We're seeing this increase in reservoir storage here in blue because of the snowpack has started to melt in the Yakima region and around the rest of Washington state as well. So the other important piece of information here is that this is the third year of drought being declared in the Yakima Basin. And so there's some longer term precipitation deficits that are playing into this. So this is taking a look on the right hand side as the standardized precipitation and evapotranspiration index for the past 2 years. And these red colors are showing a dryness exactly in this same region of the northern and central Cascades of Washington, and including the east slopes and the west slopes. And that's the same area that has been drier than usual this year, has been experiencing dry conditions earlier as well. So the senior water users in the Yakima Basin are expected to receive their full water allotment, but the junior water users, the forecast as of last month was that they would only receive 58% of their usual water allotments for the April through September period, and that forecast will be updated next week. I wanted to also quickly show our stream flow and soil moisture. So these colors here around the Pacific Northwest are mostly normal to above normal now. And again, that's mostly indicative of snowpack melting, especially in the eastern regions. And then we're also starting to see some dryness emerging on the coast of Washington and Oregon, just from, I believe, the recent 30-day dryness that we're seeing around the region. So that's something we're keeping an eye on. And then I couldn't not mention that there's also been an impact on the other side of potentially drought impacts, and that is flooding. So in Harney County in southeastern Oregon, there has been some very significant flooding near Burns. You could see on the top here, so this is a flood stage map from the National Weather Service and started at the end of March, where the river was in flood stage. It also happened again in mid-April. And so there's a couple components going into this. There's been some really rapid snow melt of the above normal snowpack in the region, but there was also a levee failure there. So this is an image I got from a news article on the left here. And then I thought this was really interesting. This is a satellite image of Burns, Oregon. And this part down here is normally Malheur Lake. And you wouldn't expect to see standing water here. So this is showing the impact of all that flooding in the area. In a normal year, you would just sort of see a smaller area of the lake here. So that's been really impactful for the folks in Burns. This is taking a look at the drought monitor, again pointing out that Oregon is sitting there looking great with no drought for the first time in a long time. There's some moderate drought across Washington and some smaller parts of Idaho. Parts of western Montana have severe drought, or yes, D3, severe drought. And overall, there's been some improvements in western Washington. I know just from monitoring that discussion closely, this is more from some of the recent precipitation that's fallen over the last 2 months. Some improvements here, and the snowpack on the Olympic Peninsula is doing a little bit better than what's going on in the Cascades of Washington. All right, so to summarize quickly, the 2025 water year has had above normal temperatures really across the whole region. Precipitation has been very variable, or aside from Oregon being wet for the most part. In the other two states, there's really a lot of regional variability in how the water year precipitation is turning out. More consistently, in the last 30 days, there's been a drier signal across the region. Our snowpack was below normal in Washington, and that combined with some multiple years of drought resulted in a drought declaration for the Yakima region, with a drought advisory, just meaning that conditions will be monitored closely for some other parts in the northern and central Cascades of Washington. Or overall, Oregon and southern Idaho are looking really good in terms of drought with higher snowpack, really good reservoir storage. And then, of course, they're seeing sort of the flip side of impacts with some flooding happening around Burns, Oregon. So with that, I'll pass it back to you, Erica.
Great, thank you, Karen. If you have questions, please post them in the Q&A and we will try to answer them after the presentations. So now I'm going to switch it over to Amy Burke. And Amy, you should be able to share your screen. And once you begin, you have 12 minutes and I'll give you a heads up at 11.
All right, I'll jump straight in here. So key takeaways for today are that the forecasts are calling for a continuation of the recent drier and warmer than normal weather that we've had. I was seeing that really across all scales of forecasts, with the exception of our near-term forecasts, which we'll look at later. Observed and forecast runoff show that same trend that Karen mentioned, being higher than normal numbers in the south and lower than normal numbers as you trend northward. Overall, the streamflow forecast at the DEWS, which is a common way for people to keep sort of tabs on the entire Columbia Basin. So that streamflow forecast currently calls for less than normal volumes for the April through September period. Drought is expected to persist in the areas currently affected by drought, or in drought declaration that Karen just showed. We'll look at that forecast as well. And while wildland fire outlooks are normal for April and May, but pick up in June and July in locations that we will look at shortly. So jumping right into recently observed precipitation and temperature, and Karen covered this really well, but I just wanted to springboard from this point of looking at April so far. So this middle map is showing a lot of red and orange on the map, indicating below normal precipitation for the month so far. This right-hand map, all this peachy color here, is indicating warmer than normal temperatures for the basin, and the seasonal precipitation forecast is here on the far left. So we see this general trend of some blue and green in the south, and some blotches of orange up in the north. So looking ahead to our 5 and 10-day precipitation forecast, these forecasts are incorporated into our water supply forecast here at the River Forecast Center. These top 2 maps are showing what is expected to fall in the next 5 days. This left-hand map is showing the inches of precipitation expected to fall, and this right-hand map is depicting that same information but as deviation from climatology or anomaly. So we can see that we will think almost everybody is going to get some rain in the next 5 days. But this right-hand map, the oranges and even the yellows are indicating areas where that rain will be less than normal. And I'm calling it rain at this point because snow is probably confined to the highest of elevations at this point. The bottom maps are showing the same information, but for the next 10 days. And you can see this precipitation here on the bottom left map is quite heavy. I did check in with meteorologists here in our office. This is depending on the placement of a low pressure system to the south of us, and some sort of wraparound precipitation that's supposed to come up from the south and hit us. So the exact amounts and location where this will hit is still unknown. It looked a little over forecast to me. So there's some thought there that in the spring when we have convective rain, it's often more isolated than the forecast depicted. And just looking at the temperature forecast and the snow line forecast for the next 10 days, I know there's a lot of plots or a lot of maps on this graphic, but really I'm just focusing on this far right row, which is showing the snow level graphics. If I saw blues and blacks on this, I would think that there was snowpack accumulation possible. Really at this point in the season, I think the snowpack building is behind us. We're in an intense melt phase at this point. I don't think that's turning around, and I just wanted to show this to show when we're expecting some warm-ups. So these reds and oranges are expected to kind of pulse on day 5 and 6, and then come into play later in the 10-day period. Essentially, take-home message here is snowpack building is behind us. We are clearly in the melt cycle at this point. And now jumping to runoff and water supply forecasts as of yesterday. This far left-hand map shows the observed runoff expressed as a percent normal for the water year thus far, so starting October 1st. Again, we see this trend of blues sort of centered around Eastern Oregon, and then things trending drier up to the north. We did have a good bit of precipitation. We had an atmospheric river come through in early October and hit what we call a top shark fin of Canada, the portion of the Columbia Basin that comes from Canada here. So that got hammered by that October storm. Likely that wet soil's there, but that runoff I wouldn't expect to have a large impact on April through September forecasts. It's likely out in the ocean already. So this middle map is showing the April through September forecasts. Again, this is the volume of water expressed as a percent normal expected to flow through the April through September period. So again, optimistic numbers, really some quite high numbers in this area of Eastern Oregon that did have that flooding that Karen mentioned. But the areas where there are concern is here on the eastern slope of the Washington Cascades, as Karen mentioned, quite lower than normal flows for the April through September forecast period there. And then on the right-hand map, I'm showing the same information but expressed as percentile. And when you get into kind of the extreme ends of things, is percentile might do a better job of depicting how these volumes compare to their own data records. So these 5s, 8s, 9s, these single digit numbers up here in Eastern Washington up into Canada are showing some quite low April through September forecasts up there. And then looking at our big three, so we have three major contributing areas to the DEWS, to the Columbia River. This area depicted in blue is the Upper Columbia above Grand Coulee Dam. And this area often gets big snowpack and is the major contributor to the volume at the DEWS. So these graphics here show the volume flowing through the river in calf or kiloacre feet on the y-axis, and then we're looking at a monthly time scale on the x. I'll note that March didn't do too bad, so this blue bar reached the green triangle, which is the normal. So for a lot of these areas, March did okay. We got a little bit above normal there. But as you can see, if you compare the current forecasts, which are these yellow box and whisker plots, which have a spread, most of them do not reach the interquartile range. This yellow rectangle here does not reach that green normal diamond for the remainder of the year. So largely below normal forecasts from here on out, including April, this current month that we're in. We don't expect any of these forecasts to reach normal this month. So this is a great way of looking at the forecast and also the timing of the melt. So we're looking at mostly normal timing here. I'm not seeing an off-kilter melt pattern showing up in the rivers yet. Jumping ahead to our monthly and seasonal outlooks from the Climate Prediction Center, I've got the monthly temperature and precipitation outlooks on the top here. We can see the northern portion of the area is colored white, indicating equal chances of above or below normal. For the rest of the area and for the seasonal, so the 3-month temperature and outlooks, we've got higher probabilities for warm and dry conditions compared to normal. And looking at the ENSO predictions, ENSO neutral is favored through the summer and even into January. You can see on this graphic here, we've got this green trend line staying near neutral all the way through. But we do see on this right-hand graphic, these blue bars, which is a chance of La Niña. We see that slowly increasing over the months, but remaining smaller than the gray bars, which are the probability of an ENSO neutral. So as of now, we're mostly looking at ENSO neutral conditions through January. And then looking at the drought monitor and outlook. So Karen showed this US drought monitor here on the left-hand side, and the right-hand maps just depict where that drought is expected to persist. And you can see these brown areas cover those areas that are currently in drought conditions. So no reason to expect that drought is going to improve at this point. or worsen. Right now, it is projected to just persist. So areas that we're keeping in mind are the eastern slope of the Washington Cascades, as well as western Montana and eastern Idaho, as you see here on the map. And then looking lastly at the wildland fire potential, I didn't put up the April and May maps because they were white for all of our region. The first I saw of red in our region was here in the upper reaches of the Columbia in BC for June. So above normal fire potential there. And then really in July, things kick in, and they are predicting above normal fire potential outlook for much of our region. So again, key takeaways from me today are that the forecasts call for a continuation of drier and warmer than normal conditions, namely precipitation and temperature, really in the next 3 months, except for that short-term forecast, which looked pretty heavy right now. We'll see how that pans out. Observed and forecast runoff are lower than normal in the north and then trend higher the further you get into southeastern Oregon in particular. But overall, the streamflow forecast coming out of the DEWS for the April through September period is lower than normal. Drought is expected to persist in those areas where it already is. And the wildland fire outlook is pretty mild until July when it really starts to pick up, and even June in the northern reaches. That's all I've got today.
Thank you so much, Amy. I don't see any questions right now, so we're doing well on time, and we'll come back to questions at the conclusion of all of the presentations. Sergio, I am making you the presenter now, so you should be able to go ahead and share your slides. And just like everyone else, you'll have 12 minutes, and I'll give you a heads up at 11.
All right, so does it look great on your end?
Looks fantastic.
Perfect. All right, good morning or good afternoon to some of you. My name is Sergio Arispe, and I'm in the Department of Animal and Rangeland Sciences at Oregon State University with a county-based appointment in Malheur County, and that's located in the southeastern corner of Oregon. Within my extension service appointment, I provide extension programming for livestock and rangeland managers managing vast landscapes. Honestly, that can be from a couple acres to millions of acres when we consider public lands that are out there as well. I point that out because the extension tools presented in this particular presentation are directly relevant to a wide breadth of participants. And as the Extension Service, we are unique in that land-grant universities provide non-formal or non-credit instruction for everyone, for our population. We take science-based information to the general public as we've been doing so in a changing manner for over the last 100+ years. So before I move on this morning, I'd really like to discuss briefly what I'll be touching. And at the end of this presentation, I really want you to be able to recall Extension Service resources relevant to mitigate negative drought impacts. And in particular, I'm going to be highlighting 3 different tools, 3 different resources that are out there and are either online or they can be online and in person. And I do want to point out that these particular tools that I'll be highlighting have been developed in collaboration with colleagues in Washington and or Idaho and Nevada. So the first tool that I want to highlight is the Inland Pacific Northwest Pasture Calendar. And last year, a group of Extension Service and Agricultural Experiment Station researchers, as well as federal agency personnel, published this Inland Pacific Northwest Pasture Calendar in the Pacific Northwest Extension Publishing Catalog. And within this pasture calendar, it utilizes a major land resource areas, which I'll call MLRAs, which are part of the USDA NRCS land classification system, comprised of land resource units, major land resource areas, and land resource regions. Now, this hierarchical system divides the country into smaller areas based on physiography, geology, climate, water, soils, biological resources, and land use. And the Inland Pasture Calendar has been developed for MLRAs and land resource regions of the Northwest Forest, Forage, and Specialty Crop Region, the Northwest Wheat and Range Region, the Western Range and Irrigated Region, as well as the Rocky Mountain Range and Forest Region. Now, the Inland Pasture region, there we go. The Inland Pasture Northwest region, or the Inland Empire, extends from the Cascade Mountains in the west to the former glacial Lake Missoula in the Rockies in the east, and from the Canada border in the north past the Snake River Canyon in the south. And this area is approximately 36,000 square miles, or 23 million acres. And the pasture calendar is designed to be a comprehensive guide for improved grassland management in support of forage livestock systems. And applying the principles described within the calendar really will lead to improved regional economic, ecological, and social sustainability. So one thing I want to highlight is this publication describes opportunities and challenges of sustainably raising harvested and grazed forages and developing forage livestock systems in this incredibly diverse environment. So the pasture calendar is a comprehensive guide for improved grassland management in support of forage livestock systems and promotes sustainable forage management to improve water and air quality. And it's designed to correctly time pasture management and activities. And as you see on these slides, you'll be able to see QR codes that will take you directly to these resources. Likewise, the Inland Pasture Northwest calendar will help identify or allow you to identify the most appropriate MLRA for the area of interest, and it's organized so that that land managers can highlight either dryland or irrigated pastures. And within the publication, it highlights 10 different growing periods for, once again, either dryland or irrigated pastures that land managers can look to and see what to expect from the vegetation out on their landscape or on irrigated fields. So I want to highlight briefly 1 and 2A within this growth period on this next slide. And that first period is highlighted semi-dormancy, and that is typically in the fall. And what this pasture calendar does highlight is what is the grass doing, environmental factors to consider, management needed, and things to avoid. It then goes to subsequent stages in growth. For example, 2A would be the steady fall regrowth, and allows land managers to determine not only what their dry land plants are doing, but also what irrigated plants are doing. And they're able to use this calendar to determine how that management. Now, on a larger scale, there's also another land management planning tool, and this is for public agencies and profitable ranches. The outcome of this particular course will walk participants through Google Earth Pro and how to use that to manage and map rangeland and irrigated pastures. Land managers are able to walk through the process to develop a threat-based land management plan, whereby they can classify private and public rangelands they manage and ultimately generate a shareable and digital land management plan that they can share within their ranch or across with public land management agencies. And there are 7 different modules within the land management planning course for public agencies and profitable ranches. And what it does, this particular course, it's offered in person in Southeastern Oregon or in a hybrid format, or is available online to the general public. Goes through GIS or Geographic Information System concepts, as well as principles in rangeland management, overview of irrigated forage production, and how to bring together precision tools such as GPSs, and also other GIS layers to develop ultimately a land management plan to support their management objectives. And here's a brief highlight in the Northern Great Basin of southeastern Oregon of just the threat-based land management tool with at lower elevations and sagebrush rangelands located in the Northern Great Basin. At lower elevations, the invasive annual grasses is the primary threat, whereas in higher elevations, the juniper expansion is the primary threat. And so this course provides private and public land managers with the vocabulary to classify healthy as well as degraded sagebrush rangelands. Now, winding up with the third and final resource is a Fine Fields Management virtual tour, and that provides land managers with ecological data and testimonials from land managers incorporating late fall and winter or dormant season grazing to restore degraded sagebrush rangelands, specifically from invasive annual grasses. And on this particular website that's available for free, there are presentations, science-based presentations from colleagues such as Dr. Karen Launchbaugh out of the University of Idaho, focusing in on targeted grazing to manage fuels. There's science-based information from Dr. Kirk Davies with USDA Agricultural Research Service to highlighting fine fuel management to mitigate fire behavior, and also from other colleagues, Dr. Jim Sprinkle and Dustin Johnson, highlighting not only grazing behavior, but ecological threats to the sagebrush rangelands in the Northern Great Basin. And at this particular website, participants are able to navigate through and learn more about ecological outcomes associated with dormant season grazing. And in this particular case is Dr. Pat Clark with USDA Agricultural Research Service out of Boise, had been grazing in the fall and winter, some BLM allotments in south of Boise. And the website really highlights what they've been doing, as well as also work in northern Nevada that have also used dormant season grazing to reduce invasive annual grasses. So ultimately, I want to thank you very much. In brief, the Extension Service has resources available for livestock producers and land managers, and each of these products have an inherent science-based framework which allows and helps land managers keep in focus positive ecological outcomes for functionally healthy lands. Thank you very much.
Great. Thank you so much, Sergio. I see that there are a couple of questions in the Q&A. Some of the speakers might want to go ahead and address those in writing, and everyone should be able to see them. We also should have an opportunity to answer a couple of questions after Amy Garrett's presentation. So Amy, I've made you the presenter. You should be able to share your slides, and like everyone else, I will give you a heads up at 11 minutes. Amy, we can't hear you if you're talking.
Thank you for that. Can you hear me now?
We can hear you, and now we can see your PowerPoint. So if you want to just, perfect, that's great.
Okay, great. Thank you. And today I'm going to share a little bit about the work of the Dry Farming Institute and one of our projects with the Western Water Resilience Collaborative. Before I get into some of that, I just want to start off with a little bit of terminology. Because some of these terms are used interchangeably, and I just want to highlight some of their different meanings. And so rain-fed agriculture, we're relying solely on precipitation for water needs, not irrigation. And dry farming, when I refer to dry farming, I'm going to be talking about crop production during a dry season in a region that receives 20 inches or more of annual rainfall. So like our climate in the western part of Washington and Oregon. And dryland farming, when I say dryland farming, I'm referring to areas that are a bit drier, like receiving less than 20 inches. And some parts of eastern parts of Washington and Oregon get closer to 10 inches of annual precipitation. And so people use those terms interchangeably, but really the two principles that come into play. So practices differ based on location, but the two basic principles of dry farming are conserving and using soil moisture, and then growing suitable plant species and varieties. And these pictures here on this slide are just snapshots of what some of our different dry farming plots in the Corvallis and Albany area the past couple of years. And this is a climograph, just kind of highlighting in Corvallis, where I'm located and where those pictures we just looked at are nearby. This is a snapshot of what our climate looks like throughout the year. So we have a lot of our rainfall, as you can see, happening in October through April, and then we're focusing in on the crop production, and from that May to October timeframe, that when we have our highest temperatures and our least amount of rainfall. And in Corvallis, we get 40 plus inches of annual rainfall. And I know whenever I give presentations in other areas, you can see that the graph looks similar, but sometimes there's 20 inches of rainfall or 30 inches of rainfall. So just wanted to highlight that real quick. So some of the basic principles and practices that support dry farming are identifying a suitable location. So you can see there on the left, there's a soil core that's been pulled 5 foot deep at a location in Philomath, Oregon. And when that soil core was pulled, we were able to notice that the water table was just 3 feet below the soil surface. So those tomatoes were just a couple feet away from accessing the water table. So there's different site characteristics such as water holding capacity and more that make a siteable more or less suitable for not irrigating. Suitable crop species is key. Getting started before the soil dries out, and that's been challenging this year since things have dried out so quickly, as the first two presenters illustrated so well. Conserving soil moisture, growers use different strategies for this, but managing weeds, or some people do different types of mulching to conserve that soil moisture in the soil from the rainy season for crops in the dry season. And microclimates, like having hedgerows that help block wind, are important. I also just want to note here that dry farming is not anything new. It's been practiced globally for millennia, and we really have gained a lot of inspiration from people in drier areas. And one of the closer areas is this, looking to the southwest here, and the Hopi have been dry farming for millennia. And Dr. Michael Katutwa Johnson gave a presentation a few years back highlighting the Hopi dry farming strategies. And the quote that he mentioned that stuck with me is, Hopi is one of the few places I know where corn is raised to fit the environment and the environment not manipulated to fit the corn. And you can see just on these two pictures on this slide that this field looks quite a bit different than the pictures I was showing you at the very beginning of my presentation of dry farming here in Western Oregon. Not going to spend a lot of time on this slide, but I just want to highlight the recent work on dry farming that we've been doing in Western Oregon. Started off at Oregon State University, and it led to the formation of a community of practice called the Dry Farming Collaborative. And then the nonprofit, the Dry Farming Institute, sort of blossomed out of this work and initiated in 2019. So I'm going to be sharing a little bit more about that. So we're a nonprofit organization with the mission to empower growers to thrive with less water. So we support growers' exploration of dry farming and other water resilient strategies or practices through collaborative projects, as well as outreach and education. And a lot of this really starts with relationships. So really through the relationships we've built over the years and listening and responding to growers' needs helps to shape our work and determine what we work on. There's a lot of different reasons different people are dry farming, and conservation, I think, is probably the most obvious one around water and energy, but also time. In a dry farming setting, there tends to be about 50% less time spent weeding, and a lot of tastings that we've done at different events. People get excited about the more concentrated flavor that tends to be in dry farmed tomatoes or melons, for example. Storability is another one. Winter squash has been shown to store many months longer when it's dry farmed versus irrigated. And then a lot of growers are just on land where there's limited access to water, or maybe not water rights, or there's not financial resources to get the irrigation system set up. So there's some different reasons people are entering into dry farming, not just conservation. Just a snapshot here of commonly dry farm crops. I think the first two, grapes, grains, and pulses, are the more common ones, or more commonly known ones. And then the ones we've been working with more so are a lot of these annual vegetables that are growing in those in our dry season. That's where a lot of our efforts have been focused. And just a recap real briefly of the basics of dry farming. So we're looking for deep soils with high available water holding capacity. We're getting started when there's still moisture in the surface to get things established. Using cultivars that are adapted to these conditions. A couple of those are pictured on the right, some Armenian cucumbers and some different types of melons that have stood out in some of our variety trials. Typically a lower planting density, so we can reduce competition for that moisture that is stored in the soil, managing weeds or mulching, and then anything we can do to improve soil health, such as minimizing disturbance, and helps and increasing organic matter, are going to be beneficial for dry farming efforts. So now I'm just going to highlight real briefly some of our recent work with the Dry Farming Institute. I'm going to spend less time on the first two and a little more time on the last one, which is related to our work with the Western Water Resilience Collaborative. So we do have a resource page that you can access at dryfarming.org/resources. And we have made an effort to highlight a lot of the resources available currently in our region and beyond. And we'll be posting new resources there as they come available. Couple most recent ones are the Dry Farming Zine, just got published last year, and that's available on our website. I know that some colleagues at OSU that I assisted in a publication on site factors influencing dry farmed vegetable productivity and quality should be coming out sometime this year. And then we've done a lot of seed to table collaborative market development work with in collaboration with the Culinary Breeding Network. So just doing a lot of education outreach with the general public and doing tastings. And we have a dry farming seed directory available, highlighting some of the varieties that have done well. So a lot of work done there, but I'm just touching on that briefly here. And now focusing in here, zooming in a little bit on our work with the Western Water Resilience Collaborative. So we've learned, there is no one-size-fits-all approach for what practices make sense on a particular site. And our work with the Western Water Resilience Collaborative has really focused in on co-learning and community building. Some of the different aspects of our project and this is in partnership with American Farmland Trust, Oregon State University, the Northwest and California Climate Hubs, as well as Washington Water Trust, and it was funded by NEFA. So we have on-farm demonstrations as well as ag professional, ag advisor workshops that I'll tell you a little bit more about upcoming ones and where to access the archived ones. And we're also doing farmer to farmer, creating opportunities for farmer to farmer learning, and that's through learning circles. And then elevating what was learned on a particular location through case studies and storytelling. So zooming in a little bit here more onto the water resilience demos we did in 2024 are the blue dots on the map, and the ones in red are the ones we were planning to do for 2025, but federal funding freeze has put a halt on that, but they do have soil moisture sensors. So we've, the whole purpose of these demos was to supply resources and support that has been helpful for us in exploring dry farming in Western Oregon and better understanding that for farmers to explore in their context. So
Amy,
this
if you
5 foot.
could be wrapping up, that would be great.
Yep, absolutely. So we've supplied these things and highlight and elevate examples of what works in different contexts. We have an ag advisor training coming up, and I'll have the link at the end. There's one on Western water rights coming up next week. If you'd like to sign up for our newsletter, there's a little QR code there. And in summary, so just highlighting that dry farming and water resilience, the practices that work will differ based on place, but the two main principles there are conserving and using soil moisture and growing suitable plant species and varieties. There's a link here on the screen to stay connected to our Western Water Resilience Collaborative work. That May 8th training on Water Rights 101 for ag advisors will be also recorded, and we'll be posting case studies in the Water Resilience Toolkit as they come available. So our YouTube channel is a great way to access our archived presentations that were mentioned here. And that's it. Thank you.
Great. Thank you so much, Amy. A couple of questions have come up, and I think our access to questions and answers may not be perfect. So thank you for bearing with us. We're going to try to at least paste answers back in. But Amy, I'll start with a question I think that was posed to you. Let's see. Is your focus more on finding land appropriate for dry farming or transforming land to be better for dry farming?
I'm sorry, was that? Sorry.
I think that was a question for Amy Garrett.
So our focus is really on supporting growers and exploring what strategies work in their context. And the soil moisture sensors, understanding soil, not just the top few inches, but to 5 foot depth, and supporting people in conducting their own variety trials if the varieties that have proved successful for us don't work for someone in another climate. So we really are emphasizing the process of exploration and yeah, really emphasizing there is no one size fits all approach. So I hope that helps clarify.
Great. Thank you. We might just have time for one more. So Karen, I know you answered this but in writing, but I think a lot of people might be interested and I'm not sure everyone can see it. Does the drier and warmer than normal weather forecast over summer mean a lower potential for lightning storms?
Yeah, excuse me. That's a good question. So the dry, warm sort of summer seasonal forecast doesn't really speak to whether there will be more or less thunderstorms. So one product that is I suggest keeping an eye on are the short-term thunderstorm outlooks from the Storm Prediction Center, and those would highlight, if we had that risk in Washington, Oregon, or Idaho.
Great, thank you. And I'm seeing something from Amy Burke, who said that thunderstorms, especially east of the Cascades, often are produced by the monsoons because of changes in airflow to a southerly direction. I think that is about all the time that we have. And so, Jason, I'll turn it to you, but maybe we want to wrap it up for today. And thank everyone so much for joining us. Thank you very much to our speakers. And again, please, when you receive a message asking for feedback, we would be very grateful for your feedback. Thank you so much, everyone.
Awesome. Sounds great, Erica. Thanks, everyone. And we'll see you next time.